Oh man, I really don't want to have to do that 174 post lab.
Yeah.
Sucks, doesn't it?
Yeah.
Interesting.
What is going on here? It looks like somebody broke this computer. Look, they gutted it. There's all the wires.
And here's an IC.
Oh no. Well, it's cool. Let's try another one. This one's not working.
How about the ones in the back?
This one's not working.
Let's try those.
Hey, wake up. Not working either.
Not working. Not working.
Did somebody break all these?
Not working. Not working.
Hey guys, there's a note.
What does it say?
Not working.
It says, that'll teach you to test manually. I guess we have to find a different way to test these ICs. So how are we going to test all these ICs?
How about probing all the pins?
That'll take way too long.
Well, what other ways do we have?
I guess we could research to try to find out.
Hey.
Okay.
All right. Computer. I think I found one. It's called Scan Chain, but it looks pretty dumb.
Ah,
Yeah.
hey, have an alternative. It's, BIST.
Built-in self-test?
Junk.
Yeah. It's complete junk.
That sounds terrible.
Yeah. Ooh, here's another one called JTAG.
JTAG?
Yeah.
Tell me more.
Okay. I know this guy Jay. He might know something about JTAG.
But we're a tag team.
But we could be a JTAG team. Boom.
So you guys want to know about JTAG? JTAG stands for Joint Test Action Group. It's named after the people who made it, AT&T, Siemens, all the electronics leaders of the day. They made this group in about 1886 to 1887. They worked on this project for about 3 years until the IEEE made it and adopted it, one of their codes, which is 1149.1. But I'm sure you guys don't really care about how this came to be. You care more about how it works, right?
That's right.
Yes.
You guys really don't like me, do you? Anyhow, this is an IC. Normally, you'd have to take your probe, like this, and go somewhere on this IC. Unfortunately, with these things getting smaller and smaller, this fine tip couldn't hit the traces right. So, as a way to get around this, and a way to test ICs when they're loaded on a PC board, we created something called Scan Chain, and it's IEEE 1149.1. That number doesn't matter. It's just one of their protocols that they adopted. Now, the reason it's important that they adopted this was because all people follow the IEEE standards, and to this day, up until about the early 2000s, actually, everyone used scan. It's not Scan Chain.
It was better than yours.
No. Scan method. Border scan. Boundary scan. Boundary scan. To this day, everyone used boundary scan. So, boundary scan is the idea that you have 4 pins. You have TKO, TSM, and TDI.
Boom.
So the idea of boundary scan, that is IEEE 1149.1, says that you can test your ICs when they're loaded on a PC board. The way that it does this is it hijacks the pins, the inputs and outputs. So if this is 2 ICs, and this is a PC that you're scanning with, by boundary scan, this PC, by the JTAG protocol, may decide to make this pin an output, that pin an input. It can hijack the pins. By doing this, these pins are actually connected inside the core logic. So, performing a set of very specific tasks, it can then go through and decide whether or not the internal logic of this is working.
Boom.
So, since nothing in electrical engineering is magic, each one of these ICs has to be set up and built with the idea that it's going to include JTAG. For this reason, there's something called a TAP controller, text access port controller. And what this does is decodes instructions sent from the PC or whatever's testing the unit and decodes that into an operation. There's 3 operations that are necessary to be JTAG protocol worthy. One is sample. This sends in an instruction to the TAP controller which says read all of the values on the ports. The second one is bypass. What this is for is if there's several ICs in a chain, it reads in an input that's specified by the TAP controller, delays it 1 clock cycle, and then outputs it to the next IC over here. And does it so on and so forth, since these are all in serial with the test data in and the test data out. At the end, when you read in the output, you can tell how many ICs were in the chain by how many clock cycles it's been delayed. X-test, which is the most important of the 3, is actually testing the logic, the core logic here of your IC. So other hardware includes the instruction register.
Hey, Cameron, wake up. I told you this guy sucks.
We can learn this on our own. Thanks. See, the only thing I don't like about this JTAG is that there's so much extra hardware.
Hey, but it's well accepted by IEEE. Hey, good standard.
I know, but the instructions are fed serially.
Hey, but it's fast.
I guess. And it is faster than doing bed of nails. I mean, who wants to read out all the voltages on every pin?
Not me. Cameron, how about you?
Not me.
All right. Looks like JTAG it is.
Okay. Look what I found. About the tab controller.
Oh, cool.
As a state machine. Let me talk about it.
All right.
It's quite simple. It has a total of 16 states. Test, logic, reset, run, test, idle, select DR, scan, capture DR, shift DR, exit 1 DR, pause DR, exit 2 DR, update DR, select IR, scan, capture IR, shift IR, exit IR, pause IR, exit 2 IR, update IR. See, very few states to deal with. These states, this load the register for like your registers that are not the instruction register. These states help you load and send out the instruction register. Quite simple. Anyways, you just have to include this in your design for any integrated circuit or device you make for each device that you want you to be able to do a JTAG test on. And that's all there's to it.
Well, now we know how to debug this computer. Let's go do it on 3. 1, 2, 3.
JTAG!
All right. Time to JTAG this thing. Look at us debug it.
Oh yeah.
Easy as that.
Hey, it works. Let's try to figure out who broke it. I think I know how to access a list. All the last user logins, exactly. Let me just hack it real quick. It was Dr. Ford. Dr. Ford, how could you?
What?